Hi physics world, my name is Alexis O'Connell, and today for our little physics discussion we're going to be talking about rotational dynamics. And in this case we're going to be talking about a Beams ultracentrifuge, which all we really need to know about Beams ultracentrifuge is that it includes rotation and it goes around in a circle. So because of that we're going to use angular velocity, angular acceleration, and the kinematic equations that correlate with those values. So here we go. This is going to be a quick one. So we know that it goes around in a circle, and we just have to keep in mind that a circle is 2 pi radians per 1 revolution. So we are given the initial angular velocity at 5 times 10 to the 5th radians per second. And it tells us that the ultracentrifuge stops. And when it stops, it has a 0 angular acceleration. And it also gives us, or it has a 0 angular velocity. And it has a negative acceleration because it is slowing down. And in the question it gives us a positive value for the acceleration, but because we know that it's slowing down, we use the negative sign. So the question is asking to find time when the angular velocity is equal to 0. So find the time before it actually stops in order for it to stop. And so to find that, we use the kinematic equation. The angular velocity in the final direction minus the initial direction equals angular acceleration times change in time. 0 minus that value we're given equals another value we're given times time. And divide by 0.40, divide by negative 0.40, and you get time, and it's a positive number, 1.25 times 10 to the 6 seconds, and that's how much time it takes to stop. The second part of the question asks for during that time it takes to stop, find the number of revolutions it traveled. So in order to find that, we need to keep in mind that the change in theta, or angular displacement, is what we need to find to solve for revolutions. But because we're all in radians per second up here and the values given, we're going to get an answer in radians and we're going to have to convert it to revolutions. That's why we need to keep in mind this conversion factor right here. 2 pi radians equals 1 revolution. Here we go. So we have initial angular velocity times the change in time plus the 1/2 acceleration times change in t squared is equal to the angular displacement. And we have this value that we're given times time, which is what we found up here, plus 1/2 acceleration, what we're given, times change in time again, what we just found, squared. And we just plug that in the calculator, subtract those values, check your units, make sure they cross out correctly to give you radians. If you don't get the correct units, you probably did something wrong. So in this case, we have a positive number of radians, and that we went around, how many times we went around. In order to convert that radians into revolutions, we can use dimensional analysis, and we could say that this number of radians that we just found is proportional to 1 revolution over 2 pi radians. And these radians cancel out, and that leaves you with 1 revolution. So if you just multiply and divide, you get 4.908 times 10 to the 11th revolutions. And if you got that, we're on the same track. I hope you enjoyed my video. Have a great day.